These will be the notes for section 9.5, dilations. The objectives are I will be able to determine whether a dilation is an enlargement, a reduction, or a congruence transformation, and I will be able to determine the scale factor for a given dilation. Let's start off with some definitions. First, dilations are a non-rigid transformation that changes the scale of a figure. A dilation is a similar transformation. That is, dilations produce similar figures. So we had a whole unit dedicated to similar triangles. So this idea of a scale factor should not be completely new to you. So a scale factor is the amount a figure is enlarged or reduced, and is symbolized by R. We figure it out by doing the image size divided by the pre-image size. So probably the best way to see this will just be to go over a few examples. If a scale factor is larger than 1, it's an enlargement. If the scale factor is smaller than 1, it's a reduction. And we have a congruence transformation if the scale factor is 1. So remember, congruent means that the figures have the exact same size and the exact same angles. Whenever we have scale factor, or whenever we have similar objects, they don't have to have the same size, but all the angles need to be the same, and all the sides need to be in proportion. So there's a couple examples to the right there of an enlargement and a reduction. Moving on to page 2, we're asked to find whether it's an enlargement, reduction, congruence, and to find the scale factor. So our original shape is right here because it's P and Q. So that's our pre-image. Our image is the smaller one. So since it's smaller, we know it's a reduction. And we have to find its scale factor. So remember, the formula for scale factor was the size of the image, which is 4 over 10. That's going to simplify to 2 over 5. So remember, R, the scale factor, is equal to the image size over the pre-image. So to do number 2, you see that our pre-image is P and our image is P prime. So this is getting larger, so it's an enlargement. So the first length we have is 15. That's our image size, or pre-image size, 15. The image size is 15 plus 15, which is 30. So the scale factor is going to be 2. So 15 plus 15. That's a mistake a lot of people make, and it's one that's pretty easy to see. So this time we're given the scale factor, and sometimes we're given the image size or the pre-image size, and we need to find the other one. So remember, CD, this is the pre-image. And if the scale factor is 3, that means we're going to take 15 times 3 to get 45. So C prime D prime is the image. So we're going to take the image size 2, but this time we're not going to multiply by R. We're going to multiply by the reciprocal of R, which is 3/2. And we get 3. So 3/2 is the reciprocal of 2/3. We use the reciprocal whenever we start off with the image and go to the pre-image. For number 5, we have the pre-image, CD. So it's going to be 16 times 5/2, which is going to be equal to 40. So now we're given a couple of things. We're asked to identify the dilation, its scale factor, and the value of the variables. So I'm going to put my pre-image in red. Sorry, that's not the pre-image, that's the post-image. The pre-image does not have the apostrophes. They don't have the primes. So red is the pre-image, and blue is the image. So we see that that's a reduction. It's getting smaller in size. So what is R equal to? We take the size of the image, 10, and we put over the original. So I'm using these numbers here, 10 and 25. Whenever I simplify that, that's going to simplify to 2/5. So if I want to find x, that's out here, that's on the pre-image side, and it corresponds to 8. So since it's on the pre-image side, I need to multiply by the reciprocal. So it's going to be 8 times 5/2, which is going to be 20. For the next one, y, I'm going to take 8 and y. Again, I'm going from the image to the pre-image, so I have to use the reciprocal. And I get 20 again. And lastly, to find z, I have 10 and z. I'm going from the image to the pre-image, so it's going to be 10 times 5/2, which is 25. So let's move on to number 7. This is my image because it doesn't have the primes on it. And the big object here, the big object is my image. The smaller one is my pre-image. So we have an enlargement. It's getting bigger. To find R, we take the sides that we know. That would be 28 and 14. Remember, the image size goes on top or in the numerator, and the pre-image goes in the denominator or on the bottom. So R is 2. Again, I'm going to go from I just noticed that I didn't mark the image correctly. This right here is the image, and the pre-image, which I'll also do in red, was right here. Doesn't change anything else that I've done. But if I need to find x, I'm going from the image to the pre-image, so I need to multiply by the reciprocal again. So I take the one that corresponds with x, which is 16. So I'm going to take 16 times 1/2. I do the reciprocal of the scale factor, and I get 8. And to solve this last one, I have 28 and 14. Or sorry, I have 32 and y, my apologies. 32 and y. So I take 32 times 1/2, and I get 16. So this is going to be the last page for dilation. We're given the scale factor, and we need to change the dimensions. So I want you to do 8 on your own. And we will do 9 together. So for number 9, we're told that the scale factor is 2/3. So that means I'm going to take, this is what my translation rule is going to be. It's going to be xy, and it's going to get transferred into 2/3 x, 2/3 y. So in order to solve for this, I'm first going to label all my points. So m is -1, 2. So that means that m prime is going to be equal to -1 times 2/3 and 2 times 2/3. So that would be -2/3, 4/3. So -2/3 is almost at -1, and my point's going to be right about there. So there's m prime. I do the same thing for these other points. I just multiply everything by 2/3, and I should get n prime is equal to 4/3, 8/3. So whenever I graph that, 4/3 is a little past 1. 8/3 is almost up to 3. So it's right about there. This is going to be n prime. And the last one I have is L prime, which is going to be 2/3 times 6, which is 4, and 2/3 times 0, which is 0. So I have L prime there. Then all I do is connect the dots. And that is my image. So with that information, I wanted to do number 9 because I didn't want to bog you down with the fractions. But all you're doing is just multiplying the x and y coordinates by the scale factor. So we'll do 10 and 11. We're asked to determine the scale factor. And we're asked to determine whether the dilation is an enlargement, reduction, or congruence. So the dashed line is the image. So for number 10, we see that it's getting smaller, so this is a reduction. So whenever I count, I see this side is 2, and the larger image is 6. So all I do is take 2 over 6, which is 1/3. That's all we need to know. This is R, and it's a reduction. For number 11, you should see that they are the same exact size, so we have congruence. You can verify that with the distance formula, which we're not going to do, and the scale factor is 1. So the only one we didn't do was an enlargement, so let's do number 12, because the shape's getting larger, so this is an enlargement. So our image is 2. And our image is 6. Our pre-image is 2. So R is going to be equal to 6 over 2, which is just 3. Number 13 you can do on your own. Hopefully dilations are making a lot of sense to you right now. Remember, we'll have more practice in class, and have a great day.